Maayong buntag ka natong tanan. Karon mag-solve kita og isa ka problem related sa first order linear ODE. Ang kini na problem kay about sa body chemical level sa atong lawas. As a chemical engineering student, mga inaning problems kay unique and intriguing para sa kuha. Dili lang sa pure chemistry field ang science sa akong degree. Naapod siya biochemistry field na mag-deal og problems related sa atong isolve karon. Makita ninyo unya kung unsa kagamit ang ES81 course with the descriptive title of Engineering Science, Mathematical Methods of Engineering 1. Sa pag-solve sa problem, since ang process gamiton kay first order linear ODE. Ganahan ko aning mga types sa problem kay mas dali ko makasabot sa process, especially about sa atong lawas. Kahibalo ba mo na ang atong mga general doctors, surgeons, internal medicine doctors, and other medical doctors kay mogamit na sila og differential equations sa ilang profession. For example, ang mga surgeons nato kay i-check nila ang rate sa growth sa inflammation sa body parts na ilang operahan para matreat nila appropriately. Mga internal medicine doctors kay i-check nila ang rate sa level sa hormones and other body fluids kapriyas anang enzymes para masakto nila og hatag ang amount sa tambal. Karon magsugod ta og atong basahon ang atong problem. Assume that the level of a certain hormone in the blood of a patient varies with time. Suppose that the time rate of change is the difference between a sinusoidal input of a 24-hour period from the thyroid gland and a continuous removal rate proportional to the level present. Set up a model for the hormone level in the blood and find its general solution. Find a particular solution satisfying a suitable initial condition. Let's assume at time is equal to 0. So like any other word problem, let's begin kung unsa ang gipangita sa problem. Una, set up a model for the hormone level in the blood. Ikaduha, find its general solution. Ikatulo, find the particular solution satisfying a suitable initial condition. So let's assume at time is equal to 0. So, for the model para sa hormone level, nasulti na siya sa first two sentences sa word problem. Assume that the level of a certain hormone in the blood of a patient varies with time. An equation of this problem would be a function of time f of t. Similarly, let's rewrite this to y of t, and let it be the level of a certain hormone in the blood, and t be the time in seconds, minutes, or hours, or it could be hours. Sa second statement, suppose that the rate of change is the difference between a sinusoidal input of a 24-hour period from the thyroid gland and a continuous removal rate proportional to the level present. Here, naa kita picture kung aha na to makita ang thyroid gland. Naa siya sa atong liog. And from the sentence, the rate of change, which is dy of t dt, is the difference between the sinusoidal input of a hormone produced sa thyroid gland and nang nagpadayon paggamit sa lawas or pagkuha gikan sa thyroid gland proportional to the level present. So mathematically written, ang thyroid gland naghimo or so produced a hormone level at a sinusoidal function. So let it be a constant A plus a constant B cosine of omega t, where omega is the bodily function or frequency of producing the hormone. And something that is used or removed, that will just be a constant k y of t. Dayon, ibutang nato siya sa atong main equation. Makukuha kita of dy of t dt is equal to a plus b cosine omega t minus ky of t. Para convenient tanawon, atong i-rewrite ang left side sa equation into y of t is equal to a plus b cosine omega t minus ky of t. Now, let's proceed sa katong unsa atong ikaduha na gipangita. Find the general solution. So, from the previous equation, y prime of t is equal to a plus b cosine omega t minus ky of t. Pwede pa natin siya ma-rewrite to another convenient na equation. So, kanina term ky of t, pwede natin siya i-transpose sa pika side or sa left side, and we will get a non-homogeneous first-order linear ODE with k, a, and b as constants. So to solve this, pangitawon na sa nato ang first ang integrating factor. So to solve for the integrating factor, the formula will just be u of x is equal to the exponential raised to the integral of p of x dx. And our equation must be in the standard form of y prime plus p of x y is equal to q of x. And from our previous equation, you will notice that it is already in the standard form. Y prime of t plus the p of x is just k. Y of t is equal to the q of x, which is a plus b cosine of omega t. Now, let's continue solving for the integrating factor. So that's just u prime of x is equal to exponential and raised to the integral of k of d of t. So let's just use t as our variable, considering that t is the one that is needed. So to solve for this, it will just be exponential raised to kt. This is our integrating factor. And to solve for the non-homogeneous linear first order, so that's the previous equation, that's y prime plus ky is equal to a plus b cosine of omega t. And putting in the integrating factor, multiplying it both sides, we will get ek of t y prime plus ky is just equal to, let's not distribute the ek of t, so it will just be the same equation as the previous one. Now for this, the left side of the equation can be transformed into a more convenient or suitable term. So it will just be d e of kt y over dt is equal to a plus b cosine omega t multiplied by e raised to the kt. So on the left side of the equation, you will notice that if you get the integral or the implicit differentiation of this one, you will get the same equation or the same answer to this if you distribute ek of t to each term of this left side of the equation. So continuing from this part, let's get the integral of this. So now the integral of d e kt y over dt, so that's dt, and integral of a plus b cosine of omega t e to the kt dt. And this will just be cancelled, so that will just be e kt y is equal to the integral of a plus b cosine omega t ekt of dt. So we're done with the left side of the equation. Now let's solve for the right side of the equation. Okay, to solve for the right side of the equation, let's distribute ek of t to each term on this sinusoidal input. So that will just be the integral of a e kt dt plus b e kt cosine omega t dt. And we will solve each of the term one by one. Okay, so to solve for the first term, a e kt of dt, since this is an exponential integral, the a constant a will just be put on the left side of the integral as a constant. And here we have to have an assumption. So we have let u is equal to kt, which is the exponential, the exponent of the exponential. So that will be du is equal to k dt, and dt is just equal to du over k. So going back to our first term, that will just be a integral of e u, and substitute dt, that's du over k. And to get that, since k is a constant, so we just have to put it on the left side of the integral, and we can now solve for the integral of the exponential. And the answer, or the integral of that, will just be e to the u. And let's substitute back our u, so that's a over k e to the kt. So we have already solved the first term. Let's proceed now to the second term. Now let's solve the second term of the right side of the equation. You can see here that the constant can be moved out of the integral, so let's do that. So that's b integral of e to the kt cosine of omega t dt. And for this integration, this can only be solved by integration by parts. So magkuha tayo sa ito mga assumptions na to. So we have let u is equal to cosine of omega t, and our dv is equal to e to the kt dt. And our differentiation for the u will just be negative w sine omega t dt, and integration of v will just be 1 over k e to the kt. So going back to the term itself, and using the formula of integration by parts, that's uv minus integral of v du. The first term of the integration by parts is okay. However, the second term will have to be solved using integration by parts also. So let's go to that term. I'll use a different ink here. So for w over k integral of e to the kt sine of omega t dt. Okay, since this can only be solved by integration by parts, let's have our assumptions here. So let u star is equal to sine omega t, and our dv star is still e to the kt dt. And the differentiation of this will just be omega cosine omega t dt, and the integration of v star is 1 over k e to the kt. And substituting this integration by parts to the other one, so we have w over k, let's put an equation sign, so that's your u star v star minus integral of v star du star. See here that this term will still have to use integration by parts to solve it. However, there is another option. Since this term is now similar to our original second term of the right side of the equation, we can just combine terms. Okay, so now let's return to our main equations where we solve each term on the right side of the equations. So in our previous slides or our papers, we know that the integral of a e k t dt was just a over k e k t. And now for the second one from the previous paper or slide, we know that b is just equal to 1 over k e to the kt cosine of omega t plus w over k squared e to the kt sine omega t all over 1 plus w squared over k squared. Now let's simplify this term to make it more convenient to look at. So still we'll just have to a over k e k t, and here just now have to make this into b over k squared plus omega squared. So that will just be k e k to e t e k t cosine omega t plus w squared e to the kt sine omega t plus c. So we also have here a constant c. So now from this equation, the left side e k t y. So let's solve for y by dividing or multiplying both sides with 1 over e to the kt. 1 over e to the kt. So we will get y is equal to a over k plus b over k squared plus omega squared k cosine of omega t plus omega squared sine omega t plus c e raised to the negative kt. We now have here our general solution. Okay, since we already solved our general solution, which is this part, atong napangitaon karon ang particular solution satisfying a suitable initial condition. So, sa nasulti na ko before na atong initial condition will be at time is equal to 0, and of course, obviously, the amount of hormone in the body will be assumed as 0 hormone. Unless i-state sa problem na naay amount at a certain level ang hormone at a certain time. So, sa pagkakaroon, mo assume lang kita na at a certain time, which is 0 minutes, there will be no hormone produced yet by the thyroid gland. So, to solve for this one, just have to place the initial value, that is y of 0 is equal to 0 So let's solve now this equation using the initial values, we get here, that's still 0, that's a over k plus, that's b over k squared plus omega squared, and the answer for this term, cosine of 0. And for the second one, that's omega squared sine of 0 plus, here we have c e to the 0. So from these initial term or conditions, we know that sine of 0 is 0, so let's cancel that. And e to the 0 is just 1, so it would just be the constant. So let's move the constant c to the left side of the equation, or make this c as the only term on that side. So if I have c here on the left side, then the other term will be negative a over k minus b over k squared plus omega squared. Here on the cosine function, the cosine of 0 is 1, so that will just left us with k. So here we have our constant, that it is negative a over k minus bk over k squared plus omega squared. Substituting this back to our general solution here, so let's do that. Now we already have our particular solution. So let's go back here to the problems. Unsa tong gipangita sa problem. So firstly, we already have set up a model. So this one, not a general solution with the constants a, b, k, omega, and c, and our particular solution, knowing that c is just equal to a over k, bk over k squared plus omega squared. So makita ninyo tanan na mostly na ay mga constants, because atong equation, atong problem kay wala man siya naghatag pod og values atong mga constants. So I hope you find this helpful. Salamat sa pagpaminaw.